Hello everyone, this is Human, and in this tutorial I'm gonna simulate the impact of a projectile into a circular disc, so stay tuned. At first we need to create our parts, so go to the part section and name the part as circular disc. So it would be 3D, deformable, solid extrusion. So continue. You need to draw a circle with the radius of 55 millimeter and the depth of 15 millimeter. So this is our circular disc. So the next thing that you need to do is going to the property section to define some mechanical properties for the disk. So it is still to define the density, you need to go to the general part. The density would be 7.85 e to the power of minus 9, which is in ton per cube millimeter. And the mechanical elasticity, you need to define the elasticity as 210 e to the power of 3 and nu as 0.3. And then go to the plastic section. The yield stress would be 120 for plastic strain of 0 and 240 for the plastic strain of 1, which means it is in 100% plasticity. So click OK and go to the create section, which would be solid homogeneous. Continue, OK, and then assign our define mechanical properties to our circular disc. So the next thing that you need to do is going to parts again and define our projectile as 3D discrete rigid solid extrusion. So it would be, again, you need to draw a circle with the radius of 17.5 millimeter and the depth of 10 millimeter. So this is your projectile. So our projectile is rigid and solid. So for decreasing the computational cost, you need to define it as shell. So go to the shape shell from solid, select our projectile, and done. So we have our projectile in shell right now. And the next thing is you need to create, at this point you need to create a reference point here, which you can choose this point as our reference point. Okay. The next step is going to assembly and bring our parts into the software as dependent. Click OK. So as you can see, the projectile is in the actual circular disc. So we need to translate our projectile. Select instance projectile. OK. So it said that select an axis or start point. So we can choose our reference point here, and the end point would be like 20 millimeter. So you need to translate it in a line with the z-axis a little bit more. So click OK, and then again instances, projectile. I think 25 millimeter would be perfect for that. Oh no, this should be 0, and the endpoint would be 25 millimeter. Yeah, that's right. And click OK. So now we assembled our two parts and translates the projectile. So the next step is going to step and define the step as initial. It would be dynamic explicit, continue. So the analgium is on, and you need to change the time period to 0.0025 and click OK. So this is for our step. The next thing that you need to do is going to mesh part, and for the circular disc, go to the global seeds and choose 3 for the approximate global size and apply to that. It's okay. So next step, this is good. At the element type section, you need to consider the explicit as elements library, and then the next point is you need to choose the element deletion as yes, because after the projectile hit the circular disc, some actual elements will be deleted, so you need to consider this element deletion as yes and click OK, and then mesh our parts. If you want, you can go here and radial axis, okay, and then yeah, that would be more better mesh. So for the projectile, you need to just consider 4.9 is good for this. Apply, yeah, it's good, and there's no need to consider the mesh deletion for this part because it's rigid, and just you can mesh it here. Again, you can go here and medial axis, and again mesh it. That would be more perfect. Okay, so after meshing our parts, we need to go to the interaction. So at first we need to create our interaction as surface to surface contact explicit. Click continue. So in this part we need to define our parts as master and slave. So the first surface would be the master one, and we need to consider our projectile as the master surface because it is solid. and it has more velocity than compared to our circular disk. So you can just consider the surface, click done. It said that choose a side for the shell or internal faces, brown or purple. So the outer shell would be brown, so you need to consider brown. And the second surface, or our slave surface, would be surface, and click here, which is our circular disk. So the first surface is our projectile, second surface the circular disk, and then we need to consider the contact interaction property between the two surfaces. So contact continue. Actually, I'll define the friction as 0.2. So go to the tangential behavior, friction load penalty, and 0.2 as the friction coefficient, and click OK, and then click OK. So the next step would be going to the load condition to define some boundary condition. Go to the boundary condition section as the initial. So first consider the encaster for plate. Continue. Need to consider this area of the circular disk, and done. So you need to choose the encaster because there will be no degree of freedom for this part of the circular disk, and we want it constant. So click OK. Afterwards, we need to set some boundary condition for our projectiles. So for our second boundary condition, you need to displacement and rotation, continue, and choose the projectile. Done. So you need to lock the velocity and also the rotation in every direction except the velocity in the Z direction, which is along the speed of our projectile. So then click OK. And then to defining the velocity for our projectile, you need to go to the predefined field and choose the velocity, continue, again choose the part which is our projectile, and consider 0, 0 and minus 100,000 millimeter per second. So our projectile goes along the z-axis with this velocity, and as it's going to the right, so it would be minus 100,000 millimeter per second, and then click OK. So the next step is defining the inertia for our projectile. So to do that, you need to go to the property and spatial inertia and create one as points mass inertia. Continue. So the projectile, you can just select our reference point here like this and click OK. And we need to define 100 gram for the mass of our projectile, which would be 0.0001 tons. and click OK. So we've already defined the mass for our projectile. So the next thing that we need to consider is defining a shear failure of 0.1 for our circular disc, owing to the fact that after the impact we need to see some failure in our circular disc. So to do that, you need to go to the model and edit keywords model 1 and come to the property section here after plastic. So you need to click here at the end and select add after, consider star, and then shear failure, and click enter, and just write down the number, which is 0.1. You need to use some space here to get the right font of as the other ones. So I think it's like this, and after that just click OK. So we've already defined shear failure for our circular disc. So at the end we just need to run our simulation. So go to the job section, define a job, continue. Again, you don't need to change the number of processors that the software used from your computer. So just go to the job manager and submit your simulation. So guys, after a while we've completely got the results, and you can click on monitor and see the step by step. Okay, after this you can go to the results section, and this is our simulation. So you can see the simulation here, and change the speed of the projectile, which, okay, this is good. So as you can see, if I change the direction here, as you can see, when the projectile hit the circular disc, as it goes along the z-axis, the distance between the elements, the failed elements and the projectile are going to be increased. So it's sort of a validation of this simulation. Because of the shear failure we've defined, and considering the fact that we chose element deletion for the circular disc in mesh section after the projectile hit the plate, the elements will be deleted. Also, you can click this and see section by section of the validation. So as you can see guys, it's fun to define and use shear failure and all such things. Suffice to say, the bullet points of this simulation is in the property section. You need to use model edit and put the shear failure very carefully, and then when you want to define the mesh for circular plates, as the meshes should be deleted after the impact, you need to consider yes for the mesh deletion. This simulation could actually be very helpful in industry, and lots of companies that their work are related to some impacts and damages, such as aerospace. Thanks for watching this tutorial. Hope you've enjoyed it. Please give us your feedback. We've always be happy to hear back from you. Also, if you need a video of a particular simulation, let us know so we can make them for you. Thanks again, and bye until the next video.